is this the same training that will be on the 28th?
No.
It's a two-part series.
You part series. Okay. I wasn't sure.
Same
All right, good
people.
morning. Good morning, everybody.
Good morning.
Hi there.
Morning.
Okay, we got 9:01. I'm ready to start. If you guys are ready to start, I'm sure you have a full agenda. You want to get going. Welcome, everybody. We are so excited that you're here today. Thank you for joining us. We Several months ago, we started talking about some of the needs that we have in state agency programs across the Commonwealth, and a recurring theme that kept coming up is we have a lot of, obviously, all of our students are engaged in math curriculum, but we don't always have content specific instructors in programs, especially smaller programs that have fewer teachers in them. And we wanted to make sure that our teachers had the resources they needed to provide exceptional learning opportunities for our kids. And that led us to a conversation with Ms. Cricket McClure at OVEC and several of her colleagues who are joining us here today about how we can provide this resources and contacts and some curriculum resources for you and others. So we thank you for being here, and we especially appreciate Ms. McClure and her team and her partners at the other educational co-ops, who I'm sure that she's going to introduce as we start. But we really appreciate your work and the support that you're providing for our teachers across the Commonwealth. And I'll turn it over to you to go ahead and get us rolling. And thank you.
Thank you. Thank you so much for having us. We're excited about this. This is a whole new world for us, guys, and we're really willing to help and be resources for you as much as we can. Let me let the folks who are on here with me today, there are more of us, but four of us are on here today. Stephanie, you want to start us off and tell us who you are?
Yes, my name is Stephanie Kidd. I am with the Kentucky Valley Educational Cooperative, and just the math consultant here. So I'll pass it on to Miss Kelly.
Hi, I'm Kelly Thompson, and I'm the math consultant for special ed for KEDC. And we service. I always use Pike County as a line because I live in Pikeville. So we service Pikeville up north toward Ashland, Lawrence County, and out toward Moorhead that way. And then Stephanie with KVEC does Pikeville and the southern counties. So my background was middle school math. I taught middle school math for several years, pre-algebra, eighth grade math, and so on. So we're just happy to let you know we're here and willing to help in any way we can.
Dwayne?
I'm Dwayne Williams. I'm with the Greater Louisville Education Cooperative. I'm a math consultant, and I service everything within Jefferson County public schools.
And I'm Cricket McClure. I'm actually at OVEC, which is all the districts kind of surrounding Jefferson County, a little bit up the river, a little bit down south, but not as many as some of the other co-ops. And Dwayne's going to explain how we're all broken up and who your particular regional consultant would be. You can reach out to any of us, guys. We're always happy to help, but you do have someone in your area who's close to where you are, who is your person to go to at any time. Please know that. We're I keep saying we're free, cheap, and easy. We don't cost anything. You can have us come in. You can Zoom with us if that's more convenient. We can find resources for you. We usually, if we don't know, we know people who might know. So please reach out to us. And we have our email addresses in here in just a minute. So I wanted to say, first of all, that our big thing, we thank you so much for those of you who replied to the survey. They gave us a much better idea of how broad the issues are with you all. And it was very interesting to read. So what we decided to do this morning is, just with so little time, we're just going to kind of hit a few big things briefly. And then we have another session scheduled on the 28th at 10 o'clock, which will also be recorded, that we're going to dig a little more deeply into integers and maybe some use of algebra tiles, some things that will help you, because what came across from the survey is that, it's middle school, high school kids, they may not be totally functioning at grade level, but you have to teach grade level math. So we're going to talk about the things that precede it and how you can get all kids engaged at that level. So let me get out here a minute and I will share the screen, and then Dwayne can Wait. Can everybody see that okay? Get this out of here.
You're good.
Yes,
Oh,
ma'am.
all right. Maybe it doesn't want to do. Why not? Okay, this was my first slide, and I just thought, which of these best represents your current feeling? I should have put one with daisies and tulips and hearts and pretty things in there, and I didn't. I'm sorry. But if you would just real quick in the chat, the scream, the tangle, or the puzzle pieces, which one is most you at this point in the year right now?
I also feel the tangle, Katie. I do.
I don't know. I think I could be the picture on the bottom left. Oh no, the end of the year is coming.
Too soon, too quickly, right?
It's like we blinked. How'd we get here?
We have a lot of puzzles.
All of above. Wow.
Yeah,
Yeah, all
yeah,
of them.
yeah.
It's just kind of a
It's that
mix.
time of year, guys, isn't it? I mean, heading down into the last little bit here on the home stretch.
Yeah.
I know that everybody's in different places with where you are, where your kids are. Um, I don't know why this is not. There you go. Dwayne, you want to jump in and explain?
Okay, so the Surtex are broken down by regions. There's 9 regions throughout the state. Um, and what I did on the next page is I'm giving you a list of all of the uh, consultants that would be responsible for your areas. And I don't know if we connected this, but this was very informative and educational for me going through. I broke down the state agency schools by the region that would serve them and put that together. And I think we were getting that double checked, but we will have that in there. But these are the consultants that you would have. The Central Kentucky Educational Cooperative is the Lexington over area. Uh, I, I'm GLEC. I've got Jefferson County Public Schools and the School for the Blind, which wouldn't really count with you guys. The Great Green River Regional Educational Cooperative is Nicole Kaiser. It goes from Elizabethtown south to the Tennessee border.
And
Kelly explained where she's at and where KVAC is at. Northern Kentucky is Kimberly Snowball, and she has everything north of what Cricket would be handling going up 71. Ovec Cricket explained that. And in Southeast South Central, we've got 2 consultants there that handle everything south of Lexington into Eastern Kentucky to a certain degree. And then Rachel Johnson is our current director at the Western Kentucky. They do not have a math consultant as of right now. They're planning on adding one by August of the school year. But any one of us, if you reach out to us, we're more than happy to meet your needs and get you resources that will help move students forward as they're going through the state agency schools.
And again, we'll send this slide deck to Katie so she can disseminate it to you all, so you can go back and figure out which co-op you're in a bit. This is not there. Okay. And this is your directory, Dwayne. So
That's the directory that I broke down.
yeah, so you'll have access to this as soon as we get it out to you today. So
Cricket, I can't open it.
oh, do you want me to open it? Okay.
No, not necessarily, because it may be the same directory that they're used to. It is. What we need to do is add the one where I broke it down by region.
Okay, well, that's what the link went to. So
Gotcha.
And that was you had all the correct information on that directory, Dwayne, that you made. The only difference was Clinton County has closed, but yeah, you had everybody assigned correctly.
Okay. Good deal.
Okay. Let
And
me
I
get
like
back
that
where I
before we
was.
leave here.
Well, it does not want to go back. Resize window.
It's not even raining today.
Huh?
It's not even raining today.
I am not able to get back to my meetings. Here we go. There. Sheesh. You are screen sharing. Where is it? Okay, guys, I've lost my screen share. Wait a minute.
Is it at the bottom or the top?
There. Maybe. Nope.
Mine's at the
At the bottom.
Usually
No,
at the bottom.
I've got the share. I just can't get the right screen up. It's not showing. I guess it's this one, and I've lost the. Heck. Let me go. I'm so sorry to keep you like this. Let me go back and reshare. Back up. Okay. Can you all see that or not?
Yes.
No?
yes.
Yes?
Yes.
What I wanted to start with is a quick activity called Which One Doesn't Belong? You may already be familiar with this. It's always a quadrant of four somethings. In this case, it's shapes. It's from a book. I'll show you in just a minute. But right now, I labeled them so you could throw this in the chat too. Which of those four figures does not belong with the other three? And you can just throw that into the chat. You can either just put the letter or and why? Why does that one not belong with the other three? And think about it from the perspective of what would your kids say if you showed them this? So D has 5 sides instead of 4. It's not a quadrilateral. What about B? Yeah. When kids look at any kid that you have, if they looked at that, what could they say? And there should be an answer for any of them. You should be able to make a case for any of them and multiple reasons for any of them. These are kind of hard to write yourself, but there are lots of places to find them if you want to try this with your kids. Kelly, yeah, see, a lot of kids have said that when I've used this with kids, that because there's no base to it. It's standing on a point, as you said. So they may have a lot of mathematical language with this, they may not, but they can all come up with a correct answer just by looking at it. So there are lots of these. This is the book. It's by Christopher Danielson. And the orange copy, but here's another one. And these are, you don't have to answer these, but I'd done this for years with kids. And then I had one kid say to me, 9 doesn't belong because all the others, the digits add up to 7. I'd looked at that 100 times and never noticed that. Here are some more, just to give you an idea. Fractions, exponents, polynomials, graphs. You can throw anything into a which one doesn't belong. Here's Christopher Danielson's major website. And you can also go, most of the ones I just showed you are from this website, Matt Rector's. If you just Google which one doesn't belong, hundreds of these will come up. And it's a quick way. It's what we call a low floor, high ceiling problem, because every kid can access it. Every kid can give an answer that's correct. And then some of the kids can come up with some phenomenal stuff on it. Questions, thoughts, anybody about that? Is there anything in the chat, Stephanie, that we need to
There's
talk about?
nothing in the chat, but one of the things I was thinking of is how much vocabulary gets brought in with the which one doesn't belong. And I love to really hone in on those vocabulary words that we look at.
And often just by using them yourself, modeling it with the kids. Yeah.
And additionally, it gives each child an opportunity to feel successful and then be able to explain their thinking, which generates conversation.
Definitely, definitely. So what I want to do today, you all asked about, mostly it came through as a constant theme, algebra, but we wanted to start with just some algebraic thinking, not necessarily flipping numbers on paper yet. And to do that, we would automatically start with something concrete, which is a little difficult to do virtually, but we're going to give it a shot here and see what we can do. Here's a pattern. I will tell you up front that it's a growing pattern. It's not a repeating pattern, and that's important, isn't it? But my question to you is, what do you see? What do you notice? What are you wondering? And what might the next step look like? This is step 1, step 2, step 3. What would step 4 look like? If you have a piece of scrap paper handy, you can draw it. I also put a link here if somebody would throw it in the chat for me, if you don't mind.
I will.
To Desmos. And if you're not familiar with Desmos, you need to jump in and try it. Here are some of the different types of manipulatives, virtual manipulatives you can find on Desmos. We'll probably use the algebra tiles and maybe the bead strings next time. But for today, I just threw in the square tiles. If you want to do it in Desmos, it's very simple. You just click on them and drag them over where you want them. So I recreated it here. It's the same pattern, but what would the 4th one look like? Go ahead and take a minute and build it or draw it. It doesn't have to be pretty, guys. Just how do you know? How would you know how to build the 4th figure in this pattern?
You have this one on Didax, not Desmos.
Oh, I'm sorry. I do.
It's fine.
I said that. I've been in
Both are
Desmos on
great.
another project. Yeah. You do need to get Desmos too. I'll say that. But yes, this is Didax. And by the way, this is free to access. So all those different manipulatives, all these, get this out of the way. All of these are available there for, and they're all very easily accessed and user friendly, I think. You just need to get in and play with it, guys.
I'm also going to drop in the chat Polypad by Amplify because it's a
Yep.
good one to use. So you'll have that one. It's got quite a few different manipulatives that you can use and plus some games that are pretty cool for the kids.
Yeah. And here's the Math Learning Center and then a Didax again. So, wait, sorry. Let me go back to our pattern. What did you notice? You can write in the chat or unmute and talk. What would the 4th one look like? How would you describe it?
Looks like Katisha said it would be 5 blocks high.
Okay. And then what else? How many tiles would there be? What would it look like?
11.
How do you know? My best question. Was everybody able to build something or draw something or to picture it? How do you know how to build the next one? What do you have to notice about these?
The pattern.
How do you see it?
I just see it getting 1 block longer on either side.
Okay. Do you see 2 long legs in there?
What do you mean by 2 long ones?
Like on the second one, how many would you say are in the leg you're looking at?
I'm counting the top one too, so it would be, the second one would be 3 on either
Okay.
side.
Does everybody see what she's saying? 3 on each side and then 1 in the middle? Is that right?
Yeah, and
How
the
do you
3
know?
across constant across the pattern.
So if that's the second one and there are 3 on each side, how many would there be on the 4th one?
5.
I'm sorry, I couldn't hear you.
5.
5 on each side with 1 in the middle. Does everybody see that way of looking at it?
Mhm.
I'm pretty sure everybody didn't see it the same way though. Somebody who saw it differently, speak up.
Michael Gregg said that the figure's getting taller and it's like a child's legs growing over time.
Definitely. Each side's growing by 1 each time, right?
Some may have seen it with 1 in figure 1, and then 2 in figure 2, 3 in figure 3, 4 in
So
figure 4.
like you're cutting the top off
Mhm.
and then looking at the parts that go down on each side, the legs. So how would we describe that? What if I said to you, what will the 10th one look like? How would you know how to build the 10th one? In the way you see it, what would the 10th one look like?
It would be an odd number.
How do you know?
Because we have 5, 7, and 9.
Okay. So you think the pattern's going to continue going up by the odd numbers?
I would think so, yes.
And if we have 2 legs, we're going to have, no matter how many we have in the 2 legs, it's going to end up being an,
Odd
if you're
number.
looking at the legs, it's going to be an even number plus the
Oh,
one in
yeah.
the middle, right?
Right.
It's going to make it odd. So that would be, if a kid said that, I'd be ecstatic and we'd be playing with, so will it always be an odd number? How do we know? High school math teachers want to just write the numbers down and play with them. I'm begging you to just look at the pattern and go that way. Had 2 dangly legs, 3 so the 10th one would have how many on the dangly legs? If the first one has 1 dangly leg and the second one has 2 on the dangly legs and the third one has 3, how much would the 10th one have?
10.
It'd have 10 on each side plus
3.
3 across the top. I don't know if this will let me. Fiddle. Sorry. I don't think it's going to let me. I do have one. I'm scared to get out and get it back into Didax, though, where I could draw on it. But some people see it with that 3 across the top and the 2 legs hanging down, right? So if we were going to write a number sentence, well, let's not even do that here. We could say whatever number I'm on, it would be that number times 2 for the legs, right? Plus 3 across the top. So we could say n, 2n plus 3 would get me the number of tiles. Does that make sense looking at it that way? The dangly legs idea? And the straight 3, because there are always 3 on the top, aren't there? So it's going to be 2 dangly legs plus the top is going to be 2 times the number I'm on plus 3. That would describe that, but everybody didn't see it that way. The first one we talked about was the whole leg with just that 1 in the middle, right?
Mhm.
So then it's going to be 2 times what? The number I'm on plus 1. If I'm on the first one, it's 2. If I'm on the second one, it's 3 on each side. If I'm on the third one, it's 4 on each side, etc. So then it would be the number I'm on plus 1 times 2, and that whole thing plus the 1 in the middle. And I hope you're following this. It's really hard to do this without writing it and drawing it and showing you, but I'm sorry. Here's one more. Here's what?
Cricket, I did a little different. I thought with the first one being 5, what I thought about was that it was 2 times the number I'm on minus 1.
Uh-huh.
So number minus 1, and then that was timesing it. So it worked out the same way because when I got to the 10th one, I did 2 times 10 minus 1, and 10 minus 1 was in parentheses. And so that would have been 9, which would have made that 18 plus 5, which would have gave me 23. So
Perfect.
they just looked at that different ways, and your
Yeah.
kids may come up with that different ways too.
Well, here's one a kid showed me that I had never thought about, because you have kids who see the whole thing and then take away what's not there. So I've had kids look at it and say, well, that first one, that's a 2 by 3. And that second one, minus 1. That second one is a 3 by 3 minus 2. The third one is a 4 by 3 minus 3. So it's whatever number I'm on plus 1. This thing. Sorry. My mouse is so sensitive. It would be the rectangle minus the part that's missing. And the part that's missing is always the number I'm on. So it would be the number plus 1 going this way times 3 in parentheses, all that in parentheses, minus the number. This one would be 2 plus 1 times 3 minus 2. This one would be 3 plus 1 times 3 minus 3, etc. I had not thought of that one. So anyway, this is a way of thinking algebraically. We can put numbers and letters to fit what we see, but we're starting just with what we see. So let me go on. Here are some questions for that. And then how do you generalize the pattern? Because, oh, I've lost a slide. No. Here's Sarah Vanderwerf. She's another good resource for you. But just looking at these ducks, without counting them one by one, how many are there? How do you see it?
19.
How'd you get it?
5, 10, 15.
So are you counting columns? I'm sorry, I don't know who said that, so I can't. 5, 10, 15, those, are you looking at the columns of ducks?
Mm-hmm.
Yeah, 10 units vertically is what they're saying.
Okay. And then I see Michael said it's 5 times 4, which would be the whole thing, minus 1. Yeah. Does everybody have a way of counting it without counting it?
Mm-hmm.
Sarah Vanderwerf thinks you should give kids one piece first and let them play with that and figure out how they see it, and then go to different ways of seeing it. These are how different people saw that one.
Nada.
Does that make sense that these are all different ways of seeing it? Some of them are additive. I'm sorry?
I think somebody was talking to their kids and they weren't muted.
Oh, okay. Okay. I thought they were trying to say something. Can you see the different ways that kids might see that, just that one figure? And then let's put it in a pattern. So it's now step 3. My first question would be, what do you see? How's the pattern growing? What do you notice? And then how would you determine the fourth one? This is the first one. This is the second one. This is the third one. What would the fourth one look like? And if we took Mr. Gregg's, he saw the whole thing times, the whole side times the whole side. This one would be, the next one would be how tall? We've got 3, 4, 5. The next one would be 6 by 5, maybe, minus 1. Does that make sense? Can you picture it? Can you draw it? Just use dots or X's or something for the ducks and figure out what the next one would look like. And then I would go back and ask about the 10th one and we would generalize from there. But for the sake of time, I'm going to go ahead and kick to the next slide, which is some ways that kids saw it. So if you look at the way it's marked on the chart first, don't look at the notation first. So in A, this kid is seeing the rows, right? You've got so many complete rows and then an incomplete row. And then so it's whatever the number is squared plus that bottom row. Does that make sense? And whatever the number is, if this is our first one, then 2 squared is plus 1, right? Squared plus the number itself. So it's n plus 1, whatever number I'm on, plus 1 squared plus the number, which is that bottom row. And then look at B. This is the kid who sees the whole thing and takes away what's not there. So if I'm on the first one, it'll be n plus 1 across and n plus 2 vertically. So 2 times 3 minus the number itself. Or I'm sorry, minus 1. It should be minus 1 on there. C, we see the number plus 2 times the number, and then the number plus 1 on the last row, column. This next one is funky. Look at D for a minute. But this kid saw things diagonally. The color coding helps. So they saw the triangles kind of at the top right and bottom left, and then they saw the rows diagonally in between. So that purple row is going to be n plus 1. That red diagonal is going to be n. And then the triangles, you're going to have the number 2 times the number times n plus 1, etc. I don't want to beat this into the ground, but there are as many ways of seeing this as you have kids. And the beauty of doing this with kids is what you can say to them is, however you see this pattern, we can put numbers and letters and things to show what you say you're thinking. That what they think is valid, the way they see it is valid. And there's not just one way to see anything in math. I like to start with this a lot because I really want to get that through to kids and to teachers. There's nothing in math that there's only one way to do or to see. And that the language that we put, the numbers and symbols and things that we put are the way we describe what we're seeing. So however you tell me you see this, we can put numbers and symbols and so on to fit what you see. It builds confidence. It lets kids make sense of the mathematics rather than just taking our word for it and flipping numbers without questioning anything. The numbers do something. Math is a language that describes what's in the real world. So anyway, I'll get off my soapbox. But this is a Sarah Vanderwerf thing that I love. Mathematics is the study of patterns. We notice patterns, we describe them, and then we generalize them, and that is algebra. So I'm going to switch gears on you for a minute. Here are the standards for mathematical practice, and we're going to run through them briefly. I'm hoping you're already familiar with them. If you're not, we can do some more with them with you, but these are part of what this is part of the KAS. This is part of what you are to be teaching every day with your kids. Actually, it's half of it, and we'll look at that real quickly. The first one is make sense of problems and persevere in solving them. If we could get kids doing this proficiently, the rest of them would all fall in line, wouldn't they? The second one is to reason abstractly and quantitatively with number. The third one is to construct viable arguments and critique the reasoning of others. That means if you want kids to justify their thinking and to look at the thinking of others and talk about it, they've got to be talking about math in your classroom. And you can get kids to do that, any kids. And we've got a lot of ways to help you do that. 4 is model with mathematics, which isn't what most people think. It doesn't mean build a model. It means that math is the way we can model the real world. We can mathematize the world around us. And we just did it with those patterns. The 5th one is use appropriate tools strategically. And tools can be anything. Tools can be a paper and pencil. Tools can be a compass, a calculator, base 10 block, you name it. But knowing when to use what tools most effectively. The 6th one is attend to precision. And I know we think that means accuracy, and it does, but it also means language. And Stephanie mentioned that earlier, and so did Kelly, that the language that they use, the labeling that we do, makes us much more precise in what we can say about things. 7 and 8 kind of go together. Look for and make use of structure, and look for and express regularity in repeated reasoning. The beautiful thing about math is it's so darn predictable. If you figure one thing out, it will keep doing that. You know, there's a regularity to it. There's a beauty to it. And my question then would be, here they are, again, all of them. There are 8. And these came from NCTM back in 2014. I mean, no, they came from the CCSSO back in 2010. Which of these did you have to use, or would your kids have to use to be successful with those patterns we just did? Did you have to make sense of it and persevere a little bit? And some of those patterns can get pretty tricky, so you really have to stick with it and dig in. Did you reason abstractly and quantitatively? Did you justify your reasoning? Did we use math to model something we saw? Did we pick tools? Unfortunately, not as well as I would like to do with you and have you do with your kids. Did we attend to precision? Did we look for, and the last two, did we look for make use of structure? Certainly. And did we look for and express regularity and repeated reasoning? Yes, because that's what a pattern is, isn't it? So when you're trying to do things with kids, people say, well, how do I teach the standards of math practice? You don't teach the standards for math practice. You teach math and use the standards for math practice to help kids understand and become more proficient thinkers. Because the bottom line in what we do is we're looking for mathematical thinking. So here are the KAS. There's the link. If you're not used to going in there, that's the quick way in. The standards for math practice are the how we do math. The standards for math content, which is what most people think of when they think of the standards, are the what of the mathematics. So we need both. We need not just the what, but also the how do proficient mathematicians do math. So what do we want kids to know content and be able to do practice mathematically? Here's a quick blurb about them again. One thing I would point out is that they are the standards for math practice that we just looked at are exactly the same K through 12. That doesn't mean that it looks the same when a kindergartner does it as it looks when a 12th grader does it, but the standards are the same. So we need to be thinking what this looks like at the grade levels we're teaching. And then the content standards actually are a three-legged stool. I have a slide for that in a minute. There's conceptual understanding, there's procedural skill and fluency, and then there's applying it, there's application, and all three are equally important. There needs to be a balanced combination. I think in the past, or at least I'm old, but when I came up through school, it was all about procedural skill. It was all about flipping numbers on paper. Now we're saying sometimes you can flip numbers on paper and not understand the math at all. So we need the understanding, we need the procedural skill, and we need to be able to apply it in novel situations. Here's a little three-legged stool to help you remember that.
Cricket, also to understand this inner standards, that also grows inner standards. So you can actually see it and label those standards for a lot of those as conceptual, as procedural, and as applying and analyzing.
Yeah,
and sorry.
KDE has a good resource in their resources that walks you through how to look for that. Yeah, online that's accessible to you. So here's what a page would look like out of the KAS. When I say, where are these? If you look at the top in the white across the top, there are those 8 standards for mathematical practice. Bless KDE's heart, they went back in and put them on every page of the standards. Every time they start a new cluster. Notice that little word cluster. That means these standards in the yellow, the content standards, all go together for some reason. And they have suggested which math practices you might want to do when you're teaching that standard. So the suggestions are there, MP1, MP3, MP6, and then the clarifications are in the kind of purpley blue. This gives you a better idea of what the rigor of the standard, where it's going, and ways you can teach it. Then in the blue that's outlined there with the red print, those are the coherence. They tell you this is sixth grade statistics and probability. This is the first content standard. So it's in the middle. Where it came from was the 5th grade measurement and data standard 2. Where it next shows up precedes 7th grade statistics and probability 1. So those are hot links. You can click right to the one that came before it or the one that's coming after it. And then at the bottom, notice below that green band, they give you much more help in thinking about how you might use those standards for math practice in this cluster. There's a lot there, and I'm afraid most people just look at the content standards and blow off the rest of it. And there's a lot of help in the standards themselves. So just want to make sure you knew that. The other big thing we wanted to throw out there today that we'll continue with, one of our best approaches to engaging all kids in the mathematics and helping them understand the mathematics is what we call CSA. It stands for concrete, semi-concrete, abstract. And concrete is literally something you can pick up and turn over and move around, something that's physically concrete. Semi-concrete is a picture, a drawing, an illustration of the concrete. And then the abstract symbols are the things we're familiar with, the numbers and symbols and so on. So Here it is with some integer pieces. So concrete is build it. Semi-concrete is draw a picture of what you built. And abstract is write it with numbers and symbols. Here's another illustration with algebra tiles. You have the actual algebra tiles, you have a picture of the algebra tiles, and then you have numbers and symbols. And again, I'm hoping when we meet again on April 28th, in our next session, we can show you some ways to use algebra tiles to help kids understand algebra better. Christina Tondevald, who's another good resource, talks about, though, we used to talk about concrete, like we'd use the manipulatives for a few days and then we'd put them away. And then we draw pictures for a few days of the manipulatives, and then we put that away. And we were trying to get kids to the abstract instead of thinking they need to see all three at once. The sweet spot is when maybe they're using the concrete pieces, you're at the board drawing, or on a slate drawing a picture of them so they can see what a picture might look like, and then you're putting symbols with it for them, or they're doing that. If you give them a problem to work, they're doing all three at the same time. I think people think of concrete as lesser than or a crutch, and it's so not. It's a way of doing math. It's a way of understanding math. I can do completing the square faster with algebra tiles than I can pulling out the formula from my memory to try to do it. It's not a hierarchy. They all need to happen at the same time. So I was going to ask, what manipulatives do you have available? And I think the folks who are here with you would be interested in knowing what you have, and have you been able to use them with your kids? What do you need also? I'm not above begging for you, I promise. Or some of us may have some we can give you or loan you or whatever if you want to try to work with some manipulatives with your kids. Here are some samples. We just saw the algebra tiles. Here are some other things that might be used in a middle school, high school classroom. And people look at these and go, wait, we had pattern blocks in the kindergarten. Guys, we can do mega algebra with pattern tiles. We can do all kinds of ratios and proportions with Cuisenaire rods. I don't know how you teach geometry without clear geoboards and angle legs. And if your kids need help with fractions, look at those fraction bars. There are multiple concrete ways of doing fractions and decimals and so on. So these are just a sampling real quick of what you might have on hand. And you probably have some other things too, I hope. My practice has been when I go into middle school or high school and they don't know if they have any manipulatives, we go look in the boiler room because somebody had them and stuck them there a long time ago. So if you're not sure if there are things where you are, I'd ask people who've been there a while, and or look in a closet somewhere and see what you have. And if you're not sure what to do with it, call one of us and we'll be there or show you on Zoom. Semi-concrete is things like number bonds, number lines, tape diagrams, grid paper, graphs. There are dozens and dozens of semi-concrete. Here are a few that can be used. And then the abstract, of course, is just the symbols. More of this at the high school level for sure. So we need to remember that there's no inherent meaning in those symbols. They always stand for something else. The meaning is in the kid's head, not in the concrete pieces, not in the symbols either. What the child knows, he can use to understand what the symbols represent. I'm going to skip through this, but I would like you to, in the next math unit you teach, how might you use concrete and or visual representations with your kids? Yeah, Stephanie, double number lines for sure. Very important in middle school and high school both. And those things go all the way through. We can start with a very simple number pathway with kindergarten and work that all the way up to that double number line. But think about it. Next time you're planning your next lesson, next unit, how could you work in concrete or visual representations for your kids? And again, if you're not sure how to do that, holler. One of us will have an idea or we'll find something for you. The big idea here is that concrete and visual representations are extremely important in developing conceptual understanding. And I'm sorry, I'm talking too much. In terms of algebra, if you asked your students what algebra is, what would they say? Put something in the chat. What would your kids say algebra is? Type it in or unmute and tell us. Besides torture, what would they say? Yeah, math with, we threw letters in, didn't we? They think they're okay till they run into those letters.
I love the
Yeah.
one that my kids say, and it's, why do we have letters now?
Uh-huh. Yeah. It's where a lot of kids hit the wall, isn't it? So let's think about it. The struggle's real. If algebra is such a useful thing, yeah, not just kids. If algebra is such a useful tool, why do kids struggle with it? You know, what are some reasons your kids struggle with math or with algebra in particular? Throw them in the chat. What are some reasons? And I know you all have lots of other unique issues and barriers and so on with your kids coming in and being so transient and having so many in one. But anyway, I get all that. But just given a kid, what are some reasons they might struggle with math, with algebra? Foundational skills, yeah. And there are lots of things that build up to this, aren't there? Other thoughts? Anybody? You can unmute, guys. It's not that many of us.
I'm going to unmute and say that having just gone through the section on concrete, semi-concrete, and then abstract, often as a student, and as Cricket said, we've been around a little while, but as a student, the teacher would jump directly to the abstract, and I didn't have that conceptual understanding, and so I would struggle because I didn't really understand what it was about. And then I know the teacher sometimes feels the pressure to go straight to the abstract because they feel they don't necessarily have time for the other concrete and semi-concrete.
Yeah. And the reality is if you spend more time on the building understanding, you have to spend less time on the flipping numbers on paper. The understand. And again, I don't know if you were like me too, Kelly. I was good at it. I could get the right answer every time, but I didn't know what I was doing. I couldn't have connected it to anything. It was just do this, do this. It's like ours is not to reason why, just invert and multiply. Yeah, there's I want kids to understand, and they can. That's my whole mission in life. They can. Math is understandable. Pam Harris, who's another resource you might want to check out, says her whole thing is math is figure outable. Her website is mathisfigureoutable.com, all one word. Some difficulties. I know you have kids with IEPs, some disability related things are memory, attention, metacognitive thinking, cognitive processing, and sometimes a reading disability. We have people all the time asking us to do word problems. Well, a lot of things that kids have difficulty with word problems have to do with reading. They could do the computation if they could figure out what to do. They just can't read and make sense of the problem. Three reach protocol is an excellent way to get at that for sure. Yes. So how can we teach so the kids struggle less and understand more? Here are some ideas. Teach conceptual knowledge, incorporate manipulatives, organizers, teaching prerequisite skills and strategies, problem solving and self-monitoring. There are just umpteen things there. And we need to do effective math teaching practice, which we didn't go into today, but one of those is you build procedural fluency from conceptual understanding. So they have to understand it before they can become fluent with it. Some other practices, and I know you'll have this slide deck, so I'm breezing through some of this given the time. It's not just symbol manipulation procedures, not just flipping numbers on a page, and those letters don't need to throw kids. We can use anything there. It's just a blank thing. So some things about algebra. Don't stop asking us to find your X. She's never coming back, and don't ask why. Look at the difference between these two representations of the same thing. If you give your kids the bottom and ask them to figure out the answer to the question mark, how much easier might that be than what's at the top? Although it's just a different way of symbolizing the same thing. Here's another one, much less threatening. And we talk about, combine like terms. What does that mean? Well, here they are, grapes with grapes, apples with apples, etc. It's just a way of getting kids to see what you're saying. and the words and expressions. We talked about language a little bit earlier, but our normal everyday language is, some of the words mean something different when we use them in algebraic thinking. So on this one, you've got terms, term and expression, and then equation. So 3x is the term. When we say combine like terms, what do we mean? 3x is the term, 3x plus 5 is an expression. We throw in an equal sign and another part, and we've got an equation. Do kids understand all that? Do they see the differences? Have I gone out of? No,
We can still see it.
yeah, I know, but it doesn't want to move. I'm having a terrible time getting it to advance is my problem. It does not want to. Come on, dude.
Well, Cricket, while you're doing that and if you're wanting your kids to succeed, always think about what's their favorite way of learning. And always start your word problems. You can take those numbers out very quickly and you can literally say, what do you feel like is going on with this story situation? Because our kids will relate back to stories. So while Miss Cricket's doing this, I'll just talk about how we can get our kids interested in those word problems or in problems, because one of the things, yes, we will see our algebra this way, but there are algebra word problems that will get them started too, that will help them to see. And if you start out by building like Miss Cricket had them doing before, and we were building and you're putting that X in there, that gets them understanding that X long before we actually get started with the algebra and we're throwing that X in, because they're seeing the patterns and they notice what's happening. And then when we throw that X in there, and maybe we just put a Post-it note where the X is, right? So they're not seeing something, what goes there. And that's what your X is. It's like, what's that number that's going to go there? So it's not as scary as seeing that X in there. Okay, take over.
Yeah, thank you. Good thing you're here. I don't know what that was, guys. I apologize. So I wanted to take a few minutes, but maybe you can just think about this later. But you as a student with algebra and your experience so far as a teacher of algebra, and how do those things affect how algebra goes in your classroom, how you do it, how kids receive it, and so on. There's a whole lot to be said about building math identity, making kids, creating a culture that is open and welcoming to kids. They feel like they belong and so on. And I realize you have short-term kids, you have lots of different things going on, but how can you quickly, easily pull the kids in and help them be successful early in their career with you? This is a Pam Harris diagram. Here's a way of showing algebraic thinking. This is like K through 12 looking across. So we start with counting strategies. We build to additive thinking, multiplicative reasoning, proportional reasoning, and then functional reasoning. But we still have counting strategies and all these other things embedded in there. And notice that spatial reasoning, algebraic reasoning, and statistical reasoning go across the whole gamut. So kids have been getting algebraic reasoning since preschool. We do it at every level. We just don't call it that. And it involves the use of patterns leading to those generalizations, study of change, and the concept of function. We were doing functions earlier with the patterns. We just didn't call it that yet. We can get kids into it, understanding it, and then give it a name.
Can you go back to that slide just 1 minute? I'm gonna throw something in there. I know we've got a lot to talk about, but I want to throw one thing in. The slide before that.
Oh,
we're having trouble. Okay, it's okay. If we're thinking about counting strategies and then additive thinking, we don't think about this very often, but when we throw in negative numbers, we have to literally go back to the counting strategy, right? And we have to use that with our negative numbers. Our kids have not seen negative numbers until they hit 5th and 6th grade. And so that's the part that it's like, where did these come from? Why are they even here? And so we have to go back to that counting strategy, getting them comfortable with that. What's before the zero? Even though they may know because of money, if I'm in the hole, in their words, what do I need to do? We have to go back to that counting strategy. That's why I love bead strings so much, is because I can go back to that counting strategy very easily. But then we have to look at it with the additive thinking and then the multiplicative thinking. So we take those negative numbers and we move through this again. Okay, that's my spiel.
No, that was great. Thanks. You don't lose what you had. You just add another layer to it, really. You build it into something going, yeah, exactly. Perfect. Um, so forms of algebraic reasoning, we've talked about. Here are some algebra tiles. Here's a picture of them. And we would like to show you how to do all things algebra with algebra tiles next time, if you're willing. Some ways of doing solving for X and or simplifying. I've more with the area model for multiplication, which is what carries into the algebra tiles. And they're laughing because I do this all the time. It's one of my things, but we could do a little bit of that as we go along. Here is an example of using algebra tiles to multiply two binomials, and just a little cartoon, a couple cartoons. So I wanted to give us time, like several minutes maybe. I hope there was at least one thing today you can take back and use. If there's something you thought, what? And we whizzed through it and you didn't have time to ask, and something that made you think a little bit, I hope today. Here we all are. And then I want to just hush and let you all, again, we'll send the slide deck out so that you'll have all this. Please feel free to contact any of us that you want to ask questions or get help from, and we will be happy to. So, questions from the audience. What can we do here? That seemed really fast to me. I know I was talking fast and I apologize. Maybe too much. Anybody?
I think Kate is muted. She was trying to say something.
Oh,
She's still muted.
Still muted.
can you get unmuted?
There we go. I was just going to say I found that fascinating as a former student because going back and seeing the manipulatives, which they didn't use with us back then, it was just
No,
here's a
none of us
worksheet.
did. Yeah.
So it's interesting to see now we're doing it a different way. So I found that very interesting.
As a teacher who was blessed in my second year, I need to go back and apologize to my first year kids. I got algebra blocks my second year and was actually trained in using them. I will say it was a game changer for my kids to be able to see the algebra in motion. And as a teacher, seeing the understanding that really popped into our kids' heads. Um, I'm I'm just saying I was blessed with that ability. And then from there, picking up on some things that my students as special ed students needed, um, and being willing to just think outside the box. Like I used a balance for negative and positive numbers for my students. So sometimes getting to it, getting to that understanding you need, you have to kind of think outside the box for your kids and bring in different things. I put up good example is I took a balance and on one side I just literally taped at the top a wonderful red, because we didn't have negative numbers on the balance, right? Pipe cleaner. And so we started from there.
Just helping students to understand that there are multiple ways to solve problems and to see math helps, again, build their confidence so that they don't have such a negative perception of math. Because sometimes you start saying, okay, let's work a little bit on math. And they're just like, because they feel like they haven't been successful. So those conversations, like Cricket demonstrated earlier, and allowing all of them to have that success helps them to be a little more attentive and feel more confident in what they're doing.
Kelly, I think that's a really good point because so many kids, when they hear the word math, they already are a little afraid. And even with adults, you'll have adults say, well, I don't know anything about math, and it's just getting that fear of math and trying to incorporate some fun in math. Some of the PD that I've attended throughout the years, one of the best things was a teacher showing how fun math could be used. And it's like, yeah, if every kid had a teacher like this that could show the fun part of math and then could go on to the other things.
Well, that's what we want to do.
Yeah, and math is fun. It should be fun for
Yes.
everybody. Yeah. Any other thoughts, questions? I don't want to keep you all, but appreciate everybody joining in today. Hope that something out of this was useful to you. If you have thoughts on what you wish we would do next time, feel free to send those too. As I said, we're thinking we'll do a little bit with integers, a little bit with algebra tiles, and whatever else we can do in an hour. And happy to keep doing this. Doesn't have to end here, you all. We can do more, or individually, we're all available to you. So please use us.
I sent out in the chat the algebra tiles. If you guys can print off those for the next time and maybe cut out some, that way you can have them at your desk to actually play with them. That may help too. And like I said, this is a print off version. I would much rather have the foam or the actual algebra tiles in your hands. But for right now, this will have to do. If you have algebra tiles, though, pull them out.
Yeah.
Great. Thank you all so much. This has been exceptional for me. I'm not a math teacher in the classroom, but I do have a daughter who's in 6th grade who says that she's going to be an engineer someday. And so as I hear all of this, it just reminds me of how critically important the foundational skills are, and building on those as we work with our kids throughout, not just those early learning, but also into those algebra years, and knowing how to effectively do that is so critically important for our kids if we're going to help them get to their goals of where they want to be. So thank you all so much. Just a reminder for everybody, we're going to come back again on April 28th, which is 2 weeks from today at 10 a.m. Eastern Time, to have our second part of this. You don't have to be at the first one to come to the second one, but we want all of you guys to come back as well. And thank you so much for joining us today and being here. And again, please reach out if you have questions. We'd be happy to pass those along or to try to field those ourselves, but we really appreciate the support today, and thank all of our friends from our various co-ops across the state, all of you guys coming together to work on this. We really appreciate it, and thank you so much.
Thank you very much for the opportunity.
All right, great. We will see everybody back here in 2 weeks at 10 a.m. on April 28th. Great. Thanks, everybody.